I'm going to talk about geometric sequences. A sequence in math is a list of numbers that are related by some rule. When we talk about a sequence being a geometric sequence, we mean a list of numbers where each term can be multiplied by a constant to get the next term. And we call this constant the common ratio. In this example sequence that I'm showing, 5, 10, 20, 40, 80, etc., we get each number by multiplying the number before it by 2. So 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, and so on. Those 3 dots at the end mean that this goes on forever. And notice that we refer to each number in our sequence as a term. So 5 is the first term, 10 is the second term, and on and on. Let's see how to use a geometric sequence in a problem. So you're going to move into your apartment and you're going to pay $500 per month, which comes to $6,000 per year. Your contract specifies that your landlord is going to raise the rent by 5% per year. Turns out that's a pretty hefty chunk. However, you decide that this is a great apartment, so you're going to stay. How much will you pay per year 20 years after you move in? And how much total rent will you have paid after 20 years of living in the same apartment? Let's see how to use geometric sequences to solve this problem. First, let's compose a sequence. So we're starting at $6,000. Now, at the end of the first year, our landlord is going to raise this rent by 5%. So we're going to have to find 5% of $6,000 and then add that number to 6,000 in order to get the next number. Then our next number is $6,300. So in our second year, we're paying $6,300. To get to where we're going to be paying in the third year, we have to take $6,300, we have to find 5% of that, add it to the $6,300, and we'll get $6,615, and so on. There's actually a shortcut way of doing this. Instead of taking 5% and then adding it to the number, what we really want to do is we want to really be able to take any one of these numbers and just multiply it by a fixed amount in order to get the next number. So it turns out with percentages, that is exactly what you can do. If I want to add 5% to 6,000, what I'm going to do is multiply 6,000 by 1.05, and that does sort of double duty. It takes 5% of 6,000 and adds it to 6,000 and gets you the next number, all in one fell swoop. Then take the $6,300, multiply that by 1.05, and you're going to get the next number. So on. All right, so we've got our sequence. So let's see, how are we going to use this sequence to figure out how much we will be paying in our 20th year? Because we don't want to do what we just did 20 times. So of course we're going to use a formula. Now remember that the first term, the number that we refer to as the first term, is what we pay in our very first year when we first move in. And our common ratio is 1.05. That first term in math for our formula we call A sub 1, and that common ratio we call R. Here's the formula. This is the formula for finding the nth term of a geometric sequence. So we want to find the 20th term. How much will we be paying in that 20th year? A sub n is equal to A sub 1 times R to the n minus 1. Let's fill in some numbers. So A sub 20, that would be the 20th number in our sequence, our 20th term, is equal to A sub 1, so that will be where we started, times R, which is our common ratio, raised to n. So remember, we're looking at 20 years, or the 20th number, 20 minus 1. Plug the numbers that we're using in our problem into our formula, Thank goodness we have a calculator to use. Take 1.05 and raise that to the 19th power. So generally on most calculators, scientific calculators or graphing calculators, you would type in the 1.05 and then there will be a symbol, a little caret, looks like a little hat. So you type that in and then type in the 19. At any rate, plug this all into your calculator and you come up with a whopping $15,161.70. So that is your rent in the 20th year of living in this apartment. Wow, I think I would move. All right. So let's go on and let's see if we can answer the second question. How much total rent? What did it all add up to after 20 years? I mean, should we have just bought a house instead? Let's see. So of course we can do it the long way. We can just start adding up all the numbers, which means we'll have to calculate 20 of the numbers by multiplying by 1.05 for each number to get the next number. Once we have 20 numbers, we'll add them all up to get our total. But of course there's a formula. So here is the formula for finding the sum of the first n terms of a geometric sequence. S sub n, so that's the sum or the total, is equal to a sub 1, remember that's where we start, our first term, times 1 minus r, and again remember r is our common ratio, so in this problem it would be 1.05, raised to the nth power, again n is how many terms we're adding up the first 20, and then all of that over 1 minus r. So filling in the numbers for our problem, we have that if we add up the first 20 terms, so s sub 20 is equal to 6,000, that's where we started, times 1 minus 1.05, remember 1.05 is our common ratio, raised to the 20th power because we're adding up 20 numbers, divide that all by 1 minus our common ratio of 1.05. Yikes. So plug that into your calculator and you come up with $198,000, $198,395.72. So that is what you'll have paid after 20 years of living in the same apartment. So, was it worth it? Well, who knows? Maybe it was a great apartment. Anyway, this is how you would use geometric sequences in a problem.